Nice.
So this research paper is like one interesting one. So like I'll show you guys something and you are going to enjoy it. So it was like in late 20 September 1950s, like back then, like it was like just 5 years like after World War II has ended, like something unusual happened. Like something at that time it was like Cold War, like when America and like some Soviet Union, they are also of that one. Some where the nations were just racing for nuclear weapons. Something new has landed on our Earth. Something from the past has came. Okay, so by it was like some kind of a piece of like an asteroid, you can say, which is like which was like a meteorite. So I believe like my colleague has talked about like what's meteorite. Okay, but I'll just go through like just like brief word. Okay. So basically like meteorites like you can find in a way that we have like red giants, for example, red giants, you know about it, like supernovas. So at that moment, like there's going to be stardust, like these dusts that are there. It is like at the moment when new stars are going to be born. So we are going to have like pre-solar clouds. These pre-solar clouds, some of them will escape. It means like we escape, nothing will happen to them. Like they will not going to be altered that much. But some of them will come like they go like for evaporization, like recomposition, like all that. So like new elements are going to be created, like silicate, metal, and sulfur. Okay, then and these ones are the survived ones. That was like it has, for example, talking about like silicate carbonate. It has like just condensed. So and this silicate carbonate is like somehow resistant against like chemical changes. Okay, then these are like combined with like something like iron bodies, you can see like an asteroid. Then this asteroid is like has broken down for some reasons. Then like when it comes like to Earth's gravity attracted and it has landed on Earth. The one that I'm going to talk about, like this research paper that I was about, is the one that has landed in this one. That has been landed in like Turkey, which is like in Maradi, which is like USA. Okay, so what we are going to study here, we are going to study like the anomalous of isotopes. Okay, that means like isotopic ratio, like new like isotopic ratio. For example, from like carbon 13 to carbon 12, it has like simple constant percentage. Okay, but when we look and study like this kind of asteroids, for example, this one here, like they are something unusual. Like just before that, this is like this is that kind of material that we imagine, and this one will be prepared for something. Right now, just talking about like something. Okay, so like for if you want like to study such a like metric, like you have to separate that means that you want to study that minerals that you want to study them. Okay, so here, so what to isolate like this, what we call this minerals, we are going to focus like on silicate carbonate. Okay, silicate carbonate. Like so to do that, first of all, we have to remove what? We have to remove like the silicates and organics. I'm not going to go deep in that. I'll just go quick. Okay, so we are going to like use like a small side like that to remove like the silicates and organics and metals and we are going to use like this. Then the scientists like the most researchers about the carbon, they have made like to spread samples. One of them they have like like extract this minerals that one of them like was like exposed to that. Okay? Then it will produce secondary ions. So in this study, the researchers have studied the azimuth ratio of carbon, nitrogen, and silicon. Okay, but because what do you call it, they didn't have like that much of the technology was not that big. Okay, so instead of like C, they could get like C2I. Okay, and for nitrogen, Cl, and for silicon, CI. Okay, so we are going to start with this one. So we are going to say carbon, nitrogen, silicon. Okay, but for that we are going to use during like our explanation of that result. I'm going to use a value which is like delta. This delta represents, just keep in mind that what is this delta about. This delta represents like this azimuth ratio by how much amount is like differs from the standard values, the standard ones that we have been compared. Okay, for example, for carbon, we are in B. Okay, so we have this, and this, and we have this one, and this one. Okay, so these are the standard ones. Researchers like what have done, they have taken data for carbon from this, and they have taken data for nitrogen from this one, and they have taken like the data for silicon from this one. These are the standard ones. Okay, and for the sample that is only in that battery, they have taken data for these ones. Then these ones are going to be compared. If they are different, it means it's not for you, right? It's not like, but it's like close. No, it's not close. But what this delta means? This delta, just keep in mind that like this is like it's just to go for carbon 13, 12. This one should be 100. The 12 is here, 12 is here, and like this, 13 is here. This is like for your sample. This one here for standards. Then if you get this one positive, it means the ratio of the outer of that battery, azimuth ratio that we have is more. It's larger. It's like higher than the ones that we have for standard ones. If it is zero, it means they are equal. If it's negative, it means it's like low. Okay, so let's see like what they have discovered. What they have done. Just a bit going to talk about it. This is like my sample. This is like my data that they have taken. Basically, this is your sample. When you have like a sample, you are getting like data here, from here, okay? So each point represents like a different area on that sample. Okay? So they have extracted these samples. So what we have over here, we have like for silicon, this we have this azimuth ratio for silicon. Okay? Silicon 13. Okay, and on this side we have it for silicon 39. But before going to that, this line representing my standard ones. Okay, my standard ones, which is like this one, mass fraction. Okay, because why these ratios actually like when they have like changed? It's like I'll talk about it in this one. So let's look at the data. Like let us look at the find something like this kind of result. Like physics. It's going to be data on science and carbon like something like that. Just understand. Okay, so let's see. If you look at this one for silicon, we have taken data for CM and CJ. And if you have forgotten like what are CJ and CM, like look, this is my CM and this is my CJ, okay? And as you see like for this, I found it like this CM like contains silicon carbonate and that. And this CGA contains silicon carbonate and the amorphous type of silicon oxide. Okay. for CF, okay, if you look like these ones are my CF, okay, and that ones are my CG. If you look for CF, it doesn't like alter that much, okay, it doesn't alter that much. The delta, which is like represents the difference between like the measured like values of this that comes from that metric to the standard one. This is like just about like 33 to 45. This is like thousand. It's not grams. Okay, it's percentage like thousand. So like for CGA, we have like a drawing. Okay, look, we have here like it's like minus 2, 1, 7. Okay, this goes all up to here. 95%, right? Which is like it's like just like away from standard ones. But why it's like that? Why it's like that? And but then like why the standard ones like it's like this fraction? Why they have changed? Why they have changed? Because they are given like for mass fraction. This mass fraction. It's like you know when the like some kind of process like evaporation, condensation, but this ones are came from outer space, like has been like preserved, okay, and they haven't like gone through that kind of reactions, like let's see, okay. So the difference, if you look like at this data, okay, I can extrapolate it like just by looking at it. I can see that there is going to be like some kind of trend over here, which I will just show you. See, there's like some kind of trend which just went from there to there. Okay? And I can make another one. Look at this one. I can see that there's another one that goes from there to there. Okay. So why this CF and CJ, why they are different? Why these two are different? Basically because of their composition. Okay? If you see because of this one, like of CGM, like this much higher than CM. Okay. This basically because of the that one, like the that one is like silicon oxide that we have off. Okay. But also we can look that we can like for example trend lines. So it means like there are like other components that the researchers they cannot like find like but they have talked about it. They have observed it, something like that. Okay? So we can say for this like the red one, I can say it has like a height. There's like another minimum which is like height is similar to 28. Okay, and another one maybe it's like in low E similar to low E that one, and one like which will have like 29. Because you don't have that, most likely going to be able to do that. So like this is like the results for what was silicon, like 29 ratio like 2 thirds. Okay, so if you look at it, it's like a really difference like from the standard one. So it means that this samples are not from them, they haven't changed. This one's not from them, they haven't changed. But in this place, they have been like because of this structure that's silicon carbide that has so, and this is like another data that we have taken. This is like this graph between like silicon carbide, this ratio we have to and also like the total ratio of like carbon to 30. If you look at this data, like basically these ones belongs to which one? Belongs to C, which is carbide and diamond. And these ones like as I told you, it's like CGA. If we look at this one, okay, if you look at over there, the CF like it changed like from carbon 13, it changed like between if you look at it like this area from 60 to around 900. This portion. Okay. This portion is like okay. And this tells us like it is typically coming from silicon carbide. Okay? But in the lower ones, these ones Okay, so like it varies. Like it's around 6,000 persons. This 6,000 is 6 times. Okay, this is it's like 6 times larger than the ones that we have already. So it suggests what? This like they are like saying silver paradigm. That's what it says. But if you look at that one, that it's over there, it seems like at least one more kind of second grain, which is very rich in carbon 13. Because as you see that we have carbon 13. That's what is that. So there must be something else over there that is rich in carbon 13. And this thing, this carbon, something that we related that this sample to the pressure that high, it's most probably has came from low intensity of a something like giant branch stars, or like from supernova. So like gives like evidence from for and of course, like this supports the idea that three grains in meteorites came from a wide variety of stars. Okay, each of them different as solutions. Even if I have like this single pattern and this single pattern here, even this single pattern is like it can these two ones can be different. And like they have like from nitrogen same thing. Okay, we have like variation like of you know like carbon 13. We have over there like for nitrogen 15. Okay, if you see this one. And for this one, this sample we have just something because C was completely like diamond and silicon carbon, right? The simple ones like this ones they are just like going to silicon ones and they are like the ones like they are like diamonds. They are mainly from diamonds. Okay, and the other ones like just the same like CGA. If you look at this one, this CGA is really low in carbon. No, it's low in nitrogen. Okay, it's low in nitrogen. Okay, anyway, if you look over there, like for CF from minus 13 to minus 14, this area, okay, and like for CGA, like nitrogen down to, and like for these ones, like they are just taking down, look at that area, okay, it's like around minus 762, okay, when it's minus means like this, atomic pressure is lower than the ones that have been detected on Earth, the ones that we have already studied there, okay, and this is, all of this like changes if you look at them, it is due to, we can see it's due to like another mineral, maybe it's over there, that's why, you know, what do you call it, that makes that silicon, okay, high in nitrogen, okay, another example, or maybe like there's maybe another example like nitrogen, like nitrogen, burn like for instance, directly, so maybe it's just like another thing that they haven't like precisely said what's it, but they just suggested that there must be something else that we haven't detected, but it is there. Okay, but they are like this. And if you look at this one, they are actually high in carbon. They are actually high in carbon, but they are somehow higher in nitrogen from this one than this one. So like this idea, like this one, this like strong evidence that at least some of these silicon carbons, grains are living in explosive stellar environments like nova. Again, because like to produce like such mineral, such like a sample, such a high, such a high isotopic ratio, there must be like, it must have been like in a region that's high in carbon, it's rich in carbon. So we can think about it now. So we can say that these ones, like they are came from like north. Okay, so
15 minutes over. 15 minutes is over, so please speed up.
okay. So okay, like over here, like what we have like first like this silicon carbon is first they have like track for example, for carbon nitrogen, they are going to like flow like this. They are being created in this cycle, CO, which is like burning carbon, nitrogen, and oxygen to develop like new elements, which operates like in hydrogen burning steps. Okay? And we are like for xenon to be processed, it must go like slow different functions. Okay? And we can find this one to giant stars. Okay. And like for neon, like from like explosive processes, for example. Okay. And this provides that that there's like a nuclear synthesis. Okay. Because this is schematic gas stage, so it knows directly that there are like nuclear synthesis that was going on and still going on. Okay, and like the summary of the findings, what they find this like was at that time was like the first detection of industrial silicon carbonate materials. Okay, and it was like the largest was like silicon carbonate energy and no gases. One components of silicon carbonate exist with different solar origins. Okay, and silicon carbonate grains are well preserved, typically resistant to solar rays. They are like preserved. This is like synthesis pathways, okay? Crystalline grain sedition conditions. Because as condensed and this medium and this silicon carbonate is like inert. It is highly resistible for chemical changes. That's why it has survived all this like way. Sorry for that.
Your question?
Presented.
Your question everybody is correct.
I don't think no one has any energy.
So, in your study, so you used a meteorite. And from this meteorite, you get a information about the pre-solar. So the meteorite was given to you, and not you. Paper was given to you for study the meteorite, which exists pre-solar age. And this is the first work, first reference or first work carried out by the scientists that they show that before the sun, there is some type of universe was there. Where that's why the sun is the first generation, the second generation star. So therefore this meteorite is coming from the early days, extremely early days, and that is the ratio what you are showing.
We are around 4.9 billion. The beginning of like formation of our sun.
So now tell me how they analyze this. They are using, you mentioned the chemical process. How do you do this? Did they mention in the paper what are the chemical process they have used to identify or get information from this meteorite that they have carbon, silicon, those things are?
Yeah, actually they haven't mentioned that in this part, okay? So, but like they have used like
What type of chemical processes
So, what kind of chemical process that
they have used to identify different elements present in this grain?
Okay, it was like about bombarding these samples like with some kind of cesium ions. It wasn't cesium ions. Okay, so in that, because like they cannot study directly carbon, nitrogen, or silicon. They were measuring like the ions of this, so that maybe they are using that one. And this, yeah, so like
What process they have used? I am asking them which way, which chemical process they have used to identify this. Because when you are using some chemical, a particular chemical, you know it can react with the oxygen, then it can form a water, then I can measure I can look at the water. Or if it is a carbon, so then you can mix with the oxygen, then you can get a carbon dioxide, and then you form a carbon dioxide and from there you can estimate how much carbon was present and that stability you can see. So my question is, so what type of chemical process they have used or mentioned in their
ones.
chemicals?
This one's
अरे उसको आदत नहीं है उसका वो टच स्क्रीन की आदत है उसको उसका लैपटॉप तो बाबा टीचर
at the same time, my goal was like to show them there's like but like they have used like strong acids like this kind of like HCl and like HCl but like we have to separate them
Like this is the silicate and the
we like to put them to separate them like
okay, that was it. Any question?
There was each of these different elements it said that it had different stellar objects. What does that mean? Different stellar objects.
different stellar objects. Okay, for example, maybe they are from nova. Okay, maybe they are from like something like giant branch. Okay,
This is from the same meteorite, so
okay, same meteorite. Okay, but what if you look at this one, like at the beginning when I talked about it, it's like same meteorite. Okay, this is the one that has to be. But this one, if you trace back, where it came from? For example, look, we have like supernova. We have like red giants. Okay, that's dust. So it's combined. Okay, and these ones are the ones that are not combined. They are zero. But they are combined. It's not so in here. They are going to stay east. That's all these ones.
Okay. No more questions. So we can thanks. So we finished